All right, so the purpose of this video is to have a discussion with my student, who happens to be my wife, Peggy, being filmed by my daughter, Anna. And of note, Peggy and I took physics classes together many years ago at the University of Illinois. So she's agreed to learn a little bit about the intensification of the western boundary currents, specifically the Gulf Stream. So I brought along my trusty globe and started out by tracing out a gyre. And so she expressed interest in knowing what a gyre is, so that's what we're going to talk about first. So all of the major ocean basins have gyres, and what a gyre is, it's a current that traces through the entire ocean basin, and it's important to know that it's driven by the winds. So we've got westerlies that tend to blow at the mid-latitudes, blowing the water from west to east, and then you've got the trade easterly winds, which tend to along the equator, which tend to blow the water, the surface water from east to west, and it sets up the circulation, or this what we call a gyre. And all of the major ocean basins have this finding. If the Earth wasn't spinning and we didn't have the Coriolis force or the Coriolis acceleration, that would be the end of it, and the currents would tend to be symmetric on the west side and on the east side. And the two vorticity terms, one would be the wind-driven surface flow, would be balanced out by the internal friction from the water itself. So far so good?
Mm-hmm.
Okay, very good. But what complicates things is that the Earth is spinning. So the Earth spins, so we're no longer in an inertial frame. We're in a continuously accelerating, and the Coriolis force is important. That's the force that drives, that gives hurricanes their rotation. But it's also the reason why, as we're going to go through, why the Gulf Stream on the western side of this basin is so much stronger and well defined than on the eastern basin. So the Coriolis force, it's actually more of an acceleration. It only affects things that are moving. So you have to have a velocity for the Coriolis force to be in effect. But in effect, if you're traveling north, the Coriolis force tends to push you to the right. When you're traveling south, it also tends to push you to the right in the direction that you're going. Again, and that's why hurricanes tend to circulate in the direction that they do. But the reason why the intensification occurs over here is because the Coriolis force varies whether you're at the equator or you're at the North Pole. So when you're at the equator, there actually is no Coriolis force. It's zero. When you're at the North Pole or the South Pole, the Coriolis force is maximal. And it's actually this difference in the Coriolis force that is the main reason why you get intensification or strengthening of the Gulf Stream as opposed to the other side. And it was a famous oceanographer named Henry Stommel who first came up with this idea. And to this time, nobody's really been able to come up with a better explanation for why the Gulf Stream is so well defined. And if you go into any of the ocean basins, for example, if you were to go into the Pacific Ocean Basin, there's also another similar type of current which flows through here, which is also very well defined, but it's only present on the western side of these ocean bases. And as you saw from the video, there's a lot of interesting things that occur along the Gulf Stream, and it's people on ships, and it affects marine life, and it's a fascinating area to study. Any questions about the Gulf Stream?
No, that was really interesting. Thank you.
Okay. And for my daughter, are there any questions?
No, I don't think so.
Okay, very good. Thank you.